Speakers today are Zakhar Diktyar, CEO of DocStudio, and Alyssa Konchenko, VP of Business Development at DocStudio. Their presentation will cover blockchain for secure document storage, notarization processes without intermediaries, and documentation. Zakhar has been a serial IT entrepreneur since 2006, with a focus on FCMG/CPG retail, and is developing experience in industries such as healthcare, insurance, finance, transportation, and oil and gas. His mission is to promote paperless work in daily business for large corporations as well as medium and small companies to provide cost savings and increased efficiency in business processes related to procurement, sales, master data management, production, and interaction with others. Alyssa Konchenko develops strategies for digitizing companies' document processes and implementing e-invoice approaches in the US and EU markets. She is an active member of several industry organizations, including EESPA, OpenPEPL, BPC e-invoice exchange market pilot, WEDI, and ASC X12. Please help me welcome Zakhar and Alyssa as they give their presentation, DocStudio as Distributed Document Ledger.
Hi, colleagues. Thank you for the invitation. Thank you for the pleasure to be here. Alyssa?
Yes, hello, everyone. Thank you very much for having us today. It's a huge pleasure for us. Today, together with Zach, we will cover the following presentation, which is DocStudio's Distributed Document Ledger. We will explore the blockchain technology, its pros and cons, and how DocStudio leverages blockchain ledger technology to provide document immutability and notarization. Please, next slide. In today's digital world, ensuring the security and integrity of documents is paramount for business. And today we'll discuss the common challenges faced by companies, which is securely providing the existence and integrity of documents. Traditional methods such as notaries or witnesses can be time-consuming. However, today we'll present an existing solution using blockchain and document ledger technology, DLT. Today, we can also point some of the benefits of using blockchain and DLT for document verification. So first of all, this is a reputable proof of document existence. Blockchain allows us to establish the document's existence at a specific moment in the past, providing undeniable evidence and eliminating any doubts. And also, this is assurance of unchanged content. By using blockchain, we ensure that the document's content remains unchanged since its very first creation. This preserves the integrity of important records and prevents unauthorized alterations. Please, next slide.
So now let's take a moment to understand what blockchain is all about. Blockchain with a capital B is a distributed database that operates on over the internet and has already about 100,000 enthusiast hosts. Each of them has its own copy of whole database. Initially designed to record transactions involving Bitcoin and other cryptocurrencies, blockchain has several key features which are important for us for this presentation. So first of all, the blockchain is add-only database. You can only post new records, but can't edit or remove existing ones. New block of data called the block added to the blockchain approximately every 10 minutes. This block contains records of transactions involving in cryptocurrencies like Bitcoin and other. In average, there are several thousands, let's say 4,000 or 5,000 interchanges or messages in each block. The very first block, known as Genesis block, was posted on the Bitcoin network or blockchain on January 3rd, 2009. And today we have about 800,000 blocks posted on the blockchain. Blockchain allow posting very short text messages using a feature called op return messaging. These messages can be up to 80 characters in length. Next slide, please. Let's explore now How blockchain can be used for the document verification. So, utilizing the blockchain for document fingerprinting, due to the size limitation of operator messages, we can't directly post the substantial document on the blockchain. However, we can post a document's fingerprint, known as a hash value. Let's talk about general understanding of hash values. A hash value is a compact and fixed size representation of large amount of data. Any modification made to the original document will result in a different hash value. Think of it as a digital equivalent of notarization. The next important aspect for us is confidentiality and flexibility. By publishing the hash value on the blockchain, we establish the authenticity and integrity of the document without revealing its actual content. This allows for confidential notarization, as the original document remains unpublished until it's needed. In summary, by utilizing hash value on the blockchain, we can establish the authenticity and integrity of the document without exposing their content. This provides a secure and flexible digital notarization solution. Next slide, please.
Today, we will also discuss the importance of blockchain's immutability in data security. So first of all, blockchain is a system that keeps a connected chain of data exchanging, ensuring transparency and accountability. Any attempts to change or delete data disrupt this chain, thus preserving the system's integrity. So the second point is the immutability of blockchain goes beyond local nodes. Even if modifications are made, the original data is preserved globally through a vast network of nodes. The third point is altering the blockchain is extremely difficult. It requires recalculating of all the hashes, which demands significant computational power and time. This makes pretty much tampering practically impossible and very easy to detect. Blockchain's immutability is a result of its structure and consensus mechanisms, which make it highly resistant to unauthorized changes. To summarize, blockchain's immutability ensures data security by preserving a connected chain of transparent and accountable data exchanges. It is resistant to unauthorized changes due to the computational challenges involved and the structure of the blockchain system itself. Next slide, please.
So let's talk about what the hash and its importance, because it's a key definition to understand what is going on in the blockchain. By definition, a hash is a cryptographic function that takes any length of the data and converts it into unique fixed length outputs. Most important key points there are: at first, this is a one-way method. Hashing is a one-way process, meaning it can be reversed to retrieve the original data. Second, the fixed length output, regardless of the input size, a hash always produces the fixed length or output. Third, consistency. The same input will always produce the same hash output. Fourth and last point, this is a popular algorithm and widely used, available for everybody. Today, SHA-256, known as the most popular hash algorithm for its security and strength. Before, it was MD5, but it became weak with the computational performance development. In summary here, a hash is a function that converts data into unique fixed length output, and this is one-way conversion, provide a consistent output, and the SHA-256 algorithm is commonly used today for hashing. Next slide, please. To ensure document integrity, it's essential to save the hash value of the document along with the document itself in a secure location. By securely storing the hash value and using the same hash function for verification, you establish a reliable method to detect any unauthorized changes to the document over time. Next slide, please. When it comes to hash function in general, there are many options available. These are just a few examples of hash functions available today. The choice of which hash functions to use depends on factors such as security requirements, performance consideration, and specific use case. And just for information, even in the Bitcoin network, in the blockchain, the hash algorithms was changed at least twice since 2009. It's important to select a hash function that aligns with the specific needs of the company and ensures the desired level of security and integrity of the data. Next slide, please. Let's reinforce these basic concepts of the hash function with a simple exercise. Hash function produce a unique hash for the input data, and even slight changes in the input will result in significantly different hash values at the output. This exercise emphasizes importance of the hash function and the verifying data integrity even when we are talking about some chain of the documents. Next slide, please. Once again, hash function is essential for data integrity, and these have practical applications. Here, why this matter. At first, uniqueness and immutability. Hash function guarantee that different inputs produce distinct hash outputs. Even slight changes in the data create completely different hash values at the output, ensuring the integrity and immutability of the data. At second, verifying document integrity. By sharing a hash value with a trusted individual, document integrity can be verified without revealing the actual content. By recalculating the hash and comparing it to the original, any modification can be detected, providing evidence of immutability. Proof of immutability versus proof of existence. Hash verification confirms the integrity of the document, but it does not prove its initial existence. It demonstrates that the document has not been altered without verifying its original existence. Hash functions offer a secure and efficient method to ensuring data integrity while preserving the confidentiality of sensitive information. Next slide, please. Thank you. So understanding the mechanics of blockchain is essential. Sorry, this is a difficult technical topic, but it's essential. Let's explore some key aspects. Blockchain operates through a network of enthusiasts, and you can post over this network or return messages recurs. And this action recurs some small fee. It's counted in the Bitcoin cents, let's say, but today the equivalent in dollars is about $5. Op-return messages attempted to be posted to the blockchain. Op-return messages attempted to be posted to the blockchain initially enter to the mempool for inclusion to the next block. It's kind of the candidates, and every 10 minutes, these candidates are coming to the new block. Because Bitcoin miners process interchanges from the mempool with the block and receive rewards when they accomplish a block. Mining Bitcoins mean found matching hash value for the entire block, where could be our op-return message. Once the block is posted, we may have a permanent proof link generated by the blockchain network for our op-return record, and that link will contain our message with our hash value. Next slide, please.
Yeah, thank you. Considering the previous slides and all the information that Doc provided, it's important to consider that blockchain has important limitations. So first of all, this is record limitations. Each records can only hold up to 80 characters. Storing large data directly on the blockchain is not feasible. The second one is pretty much cost and speed. Posting each record on the blockchain is expensive, and it's pretty much ranging from 5 to 50 United States dollars. The global blockchain network has a maximum speed of 10 transactions per second. And there is also going to be a waiting period of approximately 10 minutes for transaction confirmation. And all of this limitations present the following challenges. That storage and extensive data on the blockchain is impractical, and it is better suited to posting either hashes or so-called fingerprints. And even posting only hashes incurs some of the costs and can be slow. To sum up, that blockchain has significant advantages, but it's important to recognize the limitations that can impact its practicality and performance. However, there is a potential solution on how to overcome some of the challenges, and I think Zach will talk about this in the following slides. Next slide, please.
Yes, so let's sum up. For now, it's very attractive technology, but it's not became popular because it's kind of at least expensive, and on the other hand, it's a bit difficult technically. So let's talk about these two aspects. About the cost aspect, we may propose the following approach. We can submit to the global blockchain hash records not for each transaction, but at some interval, daily, hourly, or for each 100 of messages, while building a chain of hash values for particular document sequence internally. In such a case, data manipulation, even in theory, is only possible unless the hash, which depends on the document chain, is posted to the public blockchain. By regularly submitting hash records to the blockchain, the integrity and trustworthiness of the underlying data can be established with the same level of trust and security as it could be when you are going to post each transaction to the blockchain. This approach we may call second layer ledger, because we building, let's say, first ledger level internally, and only some, let's say, even some each 100th message we are posting to the blockchain as a second layer ledgering. Next slide, please. So thus we have a solution that combines cost optimization and trust in document management. We already call this a second layer ledger. Once again, here is the key idea. Instead of posting each document to the blockchain, we create internal chain with hash values for a large document collection and selectively post to the blockchain only every nth document, like 100th or each day or each hour, something like this. And we will have a cost for mentioned from $5 to $50 per document, only for one interchange in huge collection. To ensure trust in the blockchain, we publish this, we call it super hash, which is the last one in sequence of some number of the internal chain hashes in a public location beyond our control. This prevents any deletion or alteration of the chain, even from our side. This action is also known as anchoring to the public blockchain. With this second layer ledger and anchoring to the public blockchain, we achieve cost optimization while maintaining trust in our document collection. It's simple yet powerful approach that leverages blockchain technology. Next slide, please.
To demonstrate the practicality of the solution mentioned earlier, we have chosen to show the case where a new request form for a PIDX downstream product code and its assigned code are posted on the blockchain. With DocStudio, it's as simple as including the blockchain bots in the document processing flow. Next slide, please. Once the request form has been reviewed by the moderator and the new code assigned, it proceeds in the processing flow and reaches the blockchain bot. At this stage, the hash of the document, which can be in XML, PDF format, or both, will be directly posted on the blockchain or transmitted through a second layer ledger. Next slide, please. Within approximately 10 minutes, a new document called the DocStudio blockchain certificate will be generated in the same envelope, and this certificate will contain a permanent blockchain lien along with the other relevant data points like date and time, the block ID, etc. With the DocStudio, we pretty much provide this tool to seamlessly integrate the blockchain functionality into the document processing and make that available for everyone. And it is a straightforward and the efficient way to kind of prove and enhance the trust and security. Next slide, please.
So blockchain as a technology may contain different platforms, each with own software and so own approaches. But let's say the approach with this messaging to some public, semi-private or private blockchain will work everywhere in the mentioned and even non-mentioned platforms. Each blockchain platform has its own feature and capabilities, so it's crucial to assess their suitability for your specific needs. Factors like scalability, transaction speed, cost, and governance model can differ between platforms. By understanding these, the various blockchain platforms and their limitation, you can make a very informed decision about which platform is suitable for your requirements. Brief takeaways about our presentation. It's quite easy to use blockchain for digital notarization of business documents. With solution like DocStudio, but it's not mandatory, but it's a good one option. You can easily integrate in your daily business process this digital document ledgering, or you may call it digital notarization. And nobody will have a chance to say that your document was initially posted and later altered, changed, or deleted, because you will have cryptographic provement of this. And let's say this technology available and quite popular for at least last 10 years. But it was a huge barrier about at least the cost of this, because you had to pay about $5 per document, and for companies having millions of invoices or agreements, it's really huge budget. But now this downside is eliminated with this approach called second layer ledger, and you can enjoy this technology with any adjusted budget you want. Next slide, please. So that's it. Thank you. Please let us know if you have any question. Feel free to contact us after the webinar, or please ask any question in the chat right now.
Thank you so much, Sakar and Alyssa. We have had a few questions come in. I'm going to ask them in the order that they came in. And the first one is, what blockchain system does your service use?
We made this proof of concept project for PIDX company codes and product codes list based on the native blockchain with a capital B. Yeah, is, let's say, the oldest one. But we also had testing with Ethereum, Hyperledger Fabric, and few others. So for us, let's say, for us, all these chains is just API interface, and since we may adopt their methods, we can use all of them. It's worth to note that when you are going to post some document in DocStudio and request, let's say, blockchain notarization, the information about this proof link will be added to your audit trail certificate of document processing in DocStudio, and you will have for always link to some special website called Blockchain Explorer. Each blockchain technology has its own Blockchain Explorer site, and you will have this link forever independently from, let's say, from DocStudio. And any, let's say, PDF document you going to post on the DocStudio could be notarized, and it will have its own link. only. So the answer for the question is, let's say we're using the blockchain, and but we may use many other different platforms like it was on the previous slides.
Thank you. Our next question is, if the hashes and summaries of each transaction are stored on the chain for verification, but the transaction contents aren't, where are the transaction records themselves exchanged between parties?
The general idea that DocStudio is such a storage, or let's be neutral. So EDI platform or e-document platform should be a storage which store this document and link to the blockchain where this hash value is stored. The most valuable thing here that you are posting hash value at the place where it become immutable. Yeah. And some kind of mediator. It could be EDI or e-document provider, or it could be even your own ERP or contract lifecycle management system. It should be the storage of the information you want to notarize.
Thank you. And final question, just very quickly here, because we're just at about time. Can you give an example of a problem this is solving?
Alisa?
Yeah, I think from the very beginning of the presentation, you also mentioned that there is some issue with the document notarizations and just making sure that the document from its very first creation hasn't been changed, deleted, or any particular data within the document hasn't been changed. So this is pretty much the main case of keeping the document from its initial view, and make sure that nobody has changed it through the time.
Yes, some live samples could be, let's say, your partner complaining that you changed numbers in the invoice you issued 2 years ago, but you gonna show him, let's say, original invoice, hash value, and link to the blockchain, and it will be enough to prove that you even didn't have, in theory, the chance to, let's say, to alter this information. Another example, I don't know, some auditing company or IRS coming to some office and also complaining that some documents was posted in the past or it was changed. Yeah, and in this way you can do you can provide the proof of existence of this document in the past in the content you showed them, and many other things when any individual or corporation need to prove existence of some information or some business document in the past for some particular point in time with some particular content. Thank you.
And we even showcase some of the test exercises about the hash topic. So whenever we see the word hello, let's say that will change from the lowercase to the uppercase, the hash itself would be changed. So we pretty much record ever made changes to the documents that has been made, and if anything has been made, the initial hash would be changed, and this is pretty much the proof of the keeping the structure of the document, structure of the data safe and unchanged.
Thank you. Really appreciate it, and thank you so much, Zakar, and thank you, Alyssa, for your presentation.